All right. How are you all doing? Good? Yeah? So, probably I'm loud enough like this, right? So, I'm from Gapminder, and what we want to spread is a fact-based worldview. And how do we know if we're actually spreading that? Well, we're trying to gather facts on how fact-based people's worldviews are. So, we're asking questions to people. I want to do one of these questions with you today. Question is, how many children will there be in the year 2100? I can tell you that in 1950, we had 1 billion people. In the 2000s, we had 2 billion children. 2 billion in the 2000s. So what will it be in 2100? Will it be 2 billion, 3 billion, or 4 billion? Who says 2 billion? Raise your hand. Okay. Who says 3 billion? Okay. Who says 4 billion? Okay. So we're about 30% or something had it right. 2 billion people, actually. We are at peak child right now. There will be no more children adding. Yeah, no more children. I'm sorry. It's a very sad thing. But don't be afraid that for the people that answer it wrong, because when we ask this to representative samples of people in the world, turns out that people do very, very bad. Like 11% in Sweden, here in the US, 7% got it right. And just to show how bad that is, if you go to the zoo and you give a chimp 3 bananas, A, B, and C, it will choose 33% of the times right. So you're doing worse than the chimps. There's something very wrong there. So what is it then that's going wrong? Well, we don't think people are stupid, but people have preconceived ideas. And that's a problem. How do we get preconceived ideas? We say people have outdated worldviews from earlier education. We're not taught how to make a worldview, we're taught a worldview, and that gets outdated after a while. On top of that, our brains are biased towards survival, not towards fact-based worldviews. We have all these biases that influence us. We have confirmation bias, negativity bias. We crave for fat, sugar, and drama drama is then what we remember, so not the actual facts. And on top of that, the media amplifies our biases. You know, they need to generate clicks. They need to sell advertisements most often. So they don't really help in giving us a fact-based worldview. If you want that, don't look at the media. Don't watch the news if you want to know how the world really looks. So what is then the solution to all this? We say factfulness. So that's that lovely, calm mental state that you reach when you know your opinions are based on facts. So how do you reach that mental stage? Well, like we said, don't watch the media. We don't really believe that. It's nice, of course. You can learn things from the media. But we believe in education. So that's why we make educational material. And what does that educational material then have? First of all, of course, facts. That's important. This is kind of our basic fact framework. So we show where people live in the world. We show like the biggest change in the course of the last century is the number of babies that were born per woman. So here the colors are the different world regions, like you see them there, and where people live on income levels. So the world isn't divided into poor and the rich, but most of the people live in the middle. These kind of facts we teach people. But on top of that, you can still have correct facts and misleading worldviews. Like look at that map of Australia, except it's not Australia. These are all beautiful maps that are correct, but they give you a worldview that is misleading. So what you also need to do is to know your biases and the biases in the media, both in your brain and in the media, and try to fight them. So we try to teach people with this framework, what are the instincts that you have, like fear, and you exaggerate things, and you see gaps, or you see patterns that are not there, and how you can fight them. But enough of that, we go back to facts, because that's what we're here for, data. And we think statistics are great facts because they're by definition representative of the people. It's not just the exaggerations or the outliers, the weird people. It's everyone. That's what statistics are about. So that's already a big bias that is gone because of that. Now we come to the actual part of the talk where you all came for, hopefully. It's how we store all these facts. So we store it in something that we call DDF, which is a multi-dimensional collaborative statistics model. So basically it's just how we normally store it is a bunch of CSV files. A data set consisting of a lot of CSV files, a lot of tables. So what does that look like? Well, let's start with simple table. where we have a population, life expectancy, and GDP per capita for a country over years. And what is important here is that we define what the primary key of the table is, because everyone knows what a primary key means. Someone doesn't? Okay, good. So, because that kind of describes what the object is that we're describing. So here we say something about Sweden in 2015. And what we can do with that then is to play that over time, and you can see the bubbles move. So yeah, these bubbles, I will do that throughout the talk, show a little bit what kind of visualizations our data format allows for. So we add on extra features, and we see that we can do more things with them. So here every bubble is a country. The size of the bubble is the population size. The color is just one color for now. And here we have the income per person and life expectancy on the y-axis. So here you should have like the poor and unhealthy people, and up there somewhere the rich and healthy people. But you can see, for example, already that everything's a little bit to the left. That's because GDP per capita, or income, is a more logarithmic kind of idea. Like if you have $1, one more dollar is a lot. If you have $1,000, one more dollar is nothing. So you should have it on a logarithmic scale. But we can see later how we can do these kind of things. Now, what we also do, so this is one table. What we like to do is to put every single indicator actually in a separate table. So there we had 3 indicators in one table. Normally we put it in one CSV file per indicator, because that way if we want to switch an indicator to, for example, show CO2 per capita on the y-axis, then it only has to load one CSV file instead of all of them to just show one indicator. That'd be a bit inefficient. So yeah, this is the basic statistics. But maybe we want to say something about the countries. We want to say what the name of the country is instead of just an identifier, or in which world region they lie. So for that we have another table. We could of course add that here. Just add a column name, and you could say Sweden, and add a column world region. But that would be not normalized data, and it would be a lot of redundant data, especially if you start adding a lot of things. A lot of redundant data, you don't want that in your data set. So we create another CSV file in which we enumerate all the different countries and properties about them. So that allows us, for example, to color the bubbles by the world region they're in. So Sweden is in Europe, USA is in Americas, and now they're colored by that. So Americas are all green, Africa is blue, Asia is red, and Europe is yellow. That's nice. Indeed, and as you can see, if you hover them, they now have their actual names instead of just identifiers. But maybe we also want to say something about the world regions. We take that variable and we enumerate those. So we give names to the world regions, and we can have a topo.json file that describes what they actually look like on a map. And with that, we can draw a color legend in a map. So we already did a little bit of, our visualizations is getting nicer. Now we might want to say something more about the actual variables in our data set, have some metadata on them. Oh wait, yes. No, I'm just going to skip that. So we want to say something about the variables. We call them concepts. So every single variable, every single header basically in your CSV file that is in your data set, you enumerate it and you can say things about them. For example, what the name is, or a description of it, a methodology, how it was gathered, or what skills are allowed for it. So what you see now is that we have a logarithmic scale for income per person. That's because we defined that GDP per capita is shown preferably on a logarithmic scale, but can also be shown on a linear scale. So we can click it and change the scale to linear, and then the scale is on linear. But for life expectancy, we can't do that because only a linear scale is allowed. So we can, as a data set constructor, we can say things about the variables, and that influences right away the visualization, because you know how something should be visualized, most likely. So that's kind of the basics of DDF. We have statistics, data points. We say something about the entities in our data set, such as countries or world regions, but it can also be genders or age groups or income groups, any of those. And we describe the variables in our data set. Nice, but now comes the juicy part. This is not everything, there is more. So I introduce entity sets. Before we had a enumeration of all the countries and say something about them, but maybe we want to say something about all the geographic places in the world. So not just countries, but also cities like Singapore and Stockholm, or oceans or other places. But we want to group them in a certain way. So they're all geographic places. They all belong to the same domain. So you say for the variable geo, as we have it there, that's an entity domain, a domain of entities. And within that, you can have sets of entities that belong to that domain. This might be a bit abstract, but maybe a Venn diagram helps in explaining it, where you have that big square is the domain, or the universe, in which all the different geographic places live. And then you can draw circles around them to show which all belong to a certain set. Now, why would you want to do this? Why is this nice to do? Well, if you start defining things for these entities, for example, what its name is, or what world region, or what the population was in a certain year, you want to, when you do that once for one entity, it's done for all the types that that entity has. So when I say the name of Singapore, the name of SGP is Singapore, just count for the country. It's both for the city Singapore, and for the country Singapore, and for the UN state Singapore. So when I want to show in my visualization all the cities and their populations, or all the countries and their populations, the data for Singapore will come from the same data point. Same if I want to show all the countries, for example, like I have here. But now I want to show UN states. So for example, we now have countries, and I can show that Taiwan is right there. Taiwan is a country. But as we can see here, Taiwan is out of the UN states set. So if I switch to UN states now, then Taiwan is gone. But the nice thing is that all the other data points that are in this data set, they're still exactly the same. We don't have any redundancy in describing the population of the country China and the UN state China, or the country Singapore and the city Singapore. They're all the same. Same for the labels and all these things. And it's a better way really to describe the real world, because like I'm a person, but I'm also a son, and I'm also a tennis player, and I'm also an employee, and I'm multiple things at once, and you want to describe that in your data set. So those are entity sets. Next juicy bit, multidimensionality. So we saw population per country per year. We've seen that before in the talk, but maybe you want to say you want to split that up, because you want to say something about populations per age group per country per year, or maybe per age group per gender per country per year, or you can make it as crazy as you want, really. For example, you would want the second one to show. This is a little bit too much. Let's start off with a age pyramid. Actually, it should be. Wait, can I change that here? Probably. Yeah. Single color. So I show. This is grabbing data from this one. Here the country is actually the whole world, and the year is 2015, and we have one bar for each age group. And this is the population, how long the bar is. So we can show this, but now, for example, we want to see genders on the sides of the age pyramid. So all we have to do is change to gender, and because of the data format, it right away knows how to grab data from that table. Bam, there you have it. And you don't have to say anything about like get it from that table or something. No, I just want to see it per gender. So we add gender to the primary key of the table, and voila, you can see it. And right now we are showing the data for the world, but we can, for example, also instead showing gender on the side, show world regions on the side, on the different sides, and then this country, or actually this here country is replaced by world region, so it grabs it from a different table again. And if the data loads, so this is connecting to our servers in Sweden right now. It's a little far away. live demos. Yeah. So, another example what you can do with it. This is migration patterns in South Africa. So you can see where people move, for example, here, the capital area. A lot of people move into there. But it's interesting once you start like taking these things apart, looking in different age groups, for example. If you look at the black African population there in South Africa, you can see that youth still is all moving into the urban capital province, but elderly, they're moving the other way around because they go there to live their old lives back in the places where they came from. So pulling out the data, just taking it apart and showing disaggregations of data can be very interesting, and that's native to our data model. So it allows us to do these things very easily. Next thing is translations. That's another juicy bit. So we saw basically every string that you have in your data set, you can translate that. So we have here, for example, this file, the concepts of the data set, or the geographic places, entities, and they have like a name or a long name. And then we can start translating them to, for example, Arabic. And we just do that by copying that file and putting it in a special folder, lang, and then the language identifier. You can leave out columns like the skills column we're not interested in, or leave some translations blank, and it will just go back and take the English version. But what it allows us to do is to have a completely English data set. Like you see here, everything's English, the descriptions and whatnot. And we can then, with a push of the button, it changes it to Arabic, and our whole visualizations are able to do right to left formatting as well. And there you have it, the whole data set is in Arabic, including all descriptions, all strings basically that you have are in Arabic. So those are translations. Those were kind of all the juicy features that we have. I want to compare it a little bit to other data formats, because we try to combine things like graph formats like RDF or Freebase, if you know them. They allow this multi-typing, one entity, one node in a graph can have multiple types. But those formats are often very hard to understand. RDF is kind of generic hell. You can do a lot with it, but you really have to understand it, and it's very hard to start with that. So that's why we use nice CSV files that everyone can easily start with. You have another SDMX, maybe some of you know that. That's a format that the UN uses to interchange statistical data, but also that is very, very difficult, very strict standard to use. So we created this to have the accessibility kind of easy CSV files, but still be able to build on top of that. Like you saw, we can start with a simple statistics table, but expand it with a lot of functionalities. So DDF isn't a thing on its own. We actually use it in our data pipeline to go from data sources that live all over the world, like the UN, like the World Bank, like IHME, to transform the data in our data kitchen, harmonize it, then we host it on GitHub in the Open Numbers organization. We have a validator that validates the CSV format of DDF. We have our own MongoDB server that can host these data sets, and then the visualization framework that you saw before. By the way, that framework can also read any data format. You just have to write a reader for it, and all the visualizations are still there, or just a CSV file as well. If you want to test that, come to us and we can show you how to do that. And we use it. You can use it on your own website, these visualizations. It's an open source library, basically. So I want to show a little bit more about this data kitchen, because that's where some interesting things happen. Let's see. So we have, for example, here I show how we make our CO2 emission data set. So we have data from the CDAC. It's a US organization here that gathers information from all the countries in the world. But it has some things. It doesn't go back to the 1800s with its CO2 per capita, and we'd like to have long time series. So what we do is we create our own data set in which we do these things, and we want to harmonize all the data because CDAC uses its own identifiers for countries. The UN uses its own identifiers. World Bank uses its own identifiers. So this is not very nice to be able to. We want to show all these indicators combined, compare them with each other, see correlations. So what we do is we have, first we write a Python script that syntactically harmonizes the data, which is just means it puts it all into DDF so that it all is the same format. And then we have another Python script which you call the chef, which takes a recipe, which a recipe is a JSON or a YAML file which says like, well, take these data sets and then cut them up in this way, paste them together in another way, and out comes another DDF data set. So that's what I'm going to show you now. So what we have here is that we first transform all of these to this data from different data providers to DDF format. Then what we do here is we make our own population data set in which we take our own geo entity domains or our own identifiers for countries, and we translate the identifiers of the UN to our own identifiers, and we have our own historical time series for population that we researched based on all kinds of different sources so that we can have data back to 1800, and we have our own population data set. Now, then we do the same again with the CDAC information. We translate the identifiers of CDAC to our own identifiers, and we add our own population data set so we can have a CO2 emissions per capita. So what does such a recipe look like then? Little bit of an idea. Maybe it's a bit small, but you define ingredients. So you say, well, from the CDAC DDF data set, take all the data points. Take all the entities, so all the nations or countries, but they're called nations in CDAC, and from our own data set, take all the countries. And then you start translating, so you start cooking with these ingredients. So we start translating the column, which column, let's see, I'm a little bit lost myself now. But we take the CDAC entities, and well, basically we translate a dictionary that we define from our own gapminder entity. So we have here's all these different columns in our gapminder entities contain all kinds of different synonyms that can be used. So also synonyms that are used there, and basically it translates using that synonym dictionary to our own geo identifiers. You could take that recipe and make it into a graph. So the procedure that you just looked at is this procedure here at the translate column. But we do some other things in the recipe. For example, we merge entities like West and East Germany. We merge together to Germany. We split some entities, like for example, Russia only has data starting in 1990 because before it didn't exist. But we split them up. We split the data of the SSRU, the Soviet Republic, up in Ukraine and Russia and other SSRU states to be able to have data for just Russia also before 1990. Here we do some more things like rolling sum to get a total emissions, a cumulative sum of emissions over all of the years. This is where we draw in data points from our population data set, and we calculate CO2 per capita is the CO2 that comes from. Someone stop that? So we take the CO2 from the CDAC data set and population for ours, and then we calculate CO2 per capita, and in the end we merge it all to one nice data set. So yeah, that way we build a lot of data sets and harmonize them, and we all host them, like I said, on Open Numbers, which is a GitHub repo or GitHub organization that we run. And we really want everyone to come in and use this as well, because we want to crowdsource all these statistics. We can't do everything ourselves. We have 7 people working for us, but we need the world to to help us out and build this big data set, of course, like everyone wants. But this is our initiative of doing that. So I want to invite you all to build that fact base for the fact-based worldview together. You can look on gapminder.org /tools possibly to see our big data set. You can look up here DDF documentation and all the data sets that we have. This is our visualization framework. And here you can get in touch with me. Thank you all. Yes. By the way, this is a little bit of a commemoration of Hans Rosling. You might know him. He was our boss, but he just passed away a couple of months ago. But he always used a huge pointer. So a little bit as a remembrance to him. So if there's any questions, if there's still time. Yeah, sure.
So how do you guys handle resolving entities with separate IDs or primary keys in a bunch of different tables? Like if you have Germany spelled in a different way in multiple different data sets, is there some sort of streamlined way that you do that?
Well, basically, you have to have somewhere like defined like an ontology of synonyms for Germany, right? So we know that we call Germany GER, and then we have, like I said, we have a table basically where we have all these.
So it's like a dictionary.
Yeah, it's like a dictionary that we built in a CSV file.
Okay.
Yeah, that's how we use it. And if we find new ones, then we add them to the dictionary. Okay. Yeah. Yeah, we stop? Okay, thank you all.